do what you need to do. Yeah. So what's the small intestines look like? We have lots of bumps and ridges in there. We have villi in there. Remember the finger-like extensions because the small intestines is absorbing. So on the surface we have the microvilli that's going to pull stuff in. And then within those plica we're going to have hairs too. So when we look at our picture, we have the plica or the folds because we're trying to absorb, so we want lots of surface area. So we have this whole area. We have all those little villi on there to grab a hold of stuff. And then on the tips of the cells, we have those microvilli. So lots of finger-like extensions going on in there just to increase the surface area for absorption. So we're looking inside the small intestines. We have lots of ridges and bumps in there because that means more surface area. We have lots of villi on the surface of those. And then the cells that are making this up have the finger-like extensions on the outside of those as well.
So colonoscopy goes through the small intestine. When they do the colonoscopy, and because
colonoscopy is going rectum, anus, rectum, sigmoid colon, maybe up to decent colon. So you're not going all the way into
you're not.
small intestines.
Oh, okay.
If you're going small intestines, you're probably going through the mouth. So you're going down the esophagus, the stomach, and the small intestine. Like what your daughters had where we saw that esophagus. Did it go into the stomach? Yeah. Right. So that's what it looks like because we want to have lots of areas for surface area for absorption. I skipped a couple slides there. So, and then we have segmentation, moving things through there. Peristalsis, moving things through. Remember, segmentation is the forwards and backwards motion, and peristalsis is let's move things along action. And then the secretions are coming from other areas but dumping into the small intestines. Yes?
So if a person doesn't form a compact bowel movement,
Right.
and it settles down at the base of the toilet bowl, is that called sediment?
It depends on what, like it's just loose stuff.
Yeah, it's nothing floating on top, it's all settled down at the bottom.
Yeah, but is it solid?
No.
Just stuff.
Yeah.
Yeah. It's passing through the system too quickly.
Okay.
And it's too liquid. So it should be in the system long enough to absorb water out of it, which makes it more solid.
Okay.
And if it's passing through, then we're getting into like irritable bowel, Crohn's disease, stuff like that, where it's moving through the system quickly and it's not absorbing water out, so it's getting a lot more loose. Yeah. So that's more of an irritation kind of thing. If you have that going on. Yeah.
Okay. And I know this is gross to everybody. But what if it's just a bunch of pebbles? What does that mean?
Then it's hard. It's too hard. Liver is our largest organ next to our skin. So our liver is our largest gland in our body. It has 4 lobes. It sits over here on the right-hand side. It has 4 lobes. It has a right side and it has a left side. And then if we turn it over, it's kind of ugly looking. Turn it over. We have the gallbladder is tucked up underneath the liver. And right next to the gallbladder sits this 4-square thing called the quadrate lobe. So quad, 4-sided, 1, 2, 3, 4. So this little sac here is the gallbladder holding bile. This is the quadrate lobe. And then up here is the caudate, C-A-U, caudate. So we have a caudate and we have a quadrate. And the gallbladder goes next to the quad. That's how it works. Then we have a left lobe, and we have a great big right lobe. Coming down the middle, we have this ligament coming down. That's called the falciform ligament. Falciform ligament. So we have a small left lobe, a huge right lobe. Gallbladder has the quadrate, and then on top is the caudate. The falciform ligament separates the right and the left, but it's what helps suspend the liver in there from the diaphragm. It helps kind of connect it. So that's the falciform ligament. The liver is made up of hepatic. Liver is hepatic. The liver is made up of liver cells, hepatocytes. And when we look at a hepatocyte, it looks like a hexagon. So inside the liver, we have millions of these little cells right here. And that's what the liver is made up of, called hepatocytes, liver cells. Each one of those on every corner has this thing that we call the portal triad. So hepato means liver, portal means liver. And we have an artery, a vein, and then we have a bile duct in there. So on the corner, on each one of these 6 corners, we have a portal triad, and that's how we're supplying all the blood in and all the blood out and the bile through the liver. So the liver is one of those huge blown up sinusoidal kind of cavities. We have lots of blood flow because the liver's job is detoxification. So we want to get all the blood in there, we want to filter it, purify it, and cleanse it, and we want to get it out. We want to return the good stuff to the body and eliminate the bad stuff. So blood in through the arteries, hepatic arteries, blood in, blood out through the hepatic veins, and then bile to help us digest. So you can see all of these channels in there. The liver is very, very porous. And they're all going to drain into the central one, the central vein, and then those are all going to go out into the vena cava. So the liver is very, very, very open. The liver is very porous. The liver has lots and lots of channels. And all this purple stuff flowing, this stuff is flowing towards that central vein, and then we're going to go up and out the vena cava, of the hepatic veins and out the vena cava. So hepatocytes, they make bile. So we have the livers full of hepatocytes making the bile for us. It helps with blood glucose homeostasis. It makes cholesterol, the good cholesterol that we need to root things out. It's going to help store our fat-soluble vitamins, so D, E, A, and K. It's going to store because the liver and the gallbladder are breaking down fats, so that makes sense. That's where we would store fat-soluble vitamins. And its main job is detoxification. So lots and lots of blood coming in. We want to filter it just like the kidneys. We want to filter it, and we want to detoxify it. We want to return what we need. We want to get rid of what we don't. So just like the kidneys, different organ, different way. We're going to secrete the bile. It's going to flow all through there, and it's going to help us break down the fatty stuff that comes in. And on every corner, we have the portal triad. The portal triad is made up of a hepatic artery, vein, and bile. Portal, arterial, venular, and bile. And we're going to drain, everything is going to drain towards that central vein. And we're going to go get rid of it.
That picture there, Doctor, yeah, that picture there, that, where you see the bottom of, well, it's not, the vena cava. Yeah, that's, now the one below that. Yeah, there. Is that a continuation?
This is not the vena cava, this is the portal vein.
Okay.
Portal artery, portal vein, bile duct. This is a triad. Every corner has a little small artery, vein, and bile duct.
Okay.
And then these purple things are the pathways to get to the center vein, and those purple things are called sinusoids. We're always trying to get to the central vein. And then eventually we're going to lead to the hepatic vein, which will eventually drain into the vena cava.
So when you have cirrhosis of the liver, that's when it's affected?
All of this in here. So it gets harder and harder. The tissues aren't as spongy anymore, and it gets more sclerosed or cirrhosis, which is harder, and it's not spongy and it can't do its job. The liver is remarkable. It's the only organ in our body that we can have only 20% function and still be working. We can lose 80% function. So like in cirrhosis or hepatitis, you can lose 80% of function and the liver is still in there working because it's the largest organ. Yeah. So it's pretty remarkable. It's a huge organ. But look how porous it is. If something's not working, you have every single corner has a portal triad. And we have billions of these little, they're about the size of a sesame seed, these little cells of hepatocytes. We have billions of these. So we'll look at this model in lab this week too. And everything's draining towards the center, and then it's going to go to the central vein, and it's going to go to the hepatic vein, eventually back out to the very vein. All right, I want to finish a couple more things so it'll make sense in lab. So the gallbladder and the pancreas, remember the gallbladder is tucked up underneath the liver, and it can palpate it if you find your sternum, your xiphoid process. You go over about 2 fingers, take a breath in, and when you come out, you can go under there. If you poke in there and it's tender, then it's probably your gallbladder that's causing you some problems. So it's tucked in right underneath it. And if it's really irritated, you can feel it. It like bulges out right there. So it's right along your rib cage, right underneath.
If you don't have one, you shouldn't feel it.
If you don't have it, you shouldn't be feeling it. So remember, the gallbladder lives under the liver, and it's secreting bile, which is coming down into the duodenum. And the pancreas is secreting all kinds of things, including insulin and glucagon. And they're coming right over here to this connection. And that's called the hepato for liver, pancreatic for pancreas, pancreas. So we're going to have this duo combination of the gallbladder and the pancreas helping with absorption in the small intestines. So the function is to chemically digest fats from the gallbladder, and it's going to start in the duodenum because that's where we're dumping it in. And the gallbladder is going to secrete bile salts, and bile salts are going to emulsify or break down fats. When you have a fatty dish and you're washing dishes, and you put dish soap in it, and all those fat globules break up, that's what bile does. It's an emulsifier. It breaks up big chunks of fat into little pieces, and then we can eliminate it. So the gallbladder secretes bile salts, which help break things down, and then the pancreas is going to secrete pancreatic lipase, which is an enzyme that's going to help break down light fats. So the pancreas is also going to help break down fats as well. And they're going to come down, so it's coming from the gallbladder, it's coming from the pancreas. They're dumping right into that corner of the duodenum. So the gallbladder is a thin-walled green muscular sac on the ventral surface, the front surface of the liver. It's going to store bile, and it's going to release bile when the time is right. It's going to release through the cystic duct, and it's going to flow down a common duct, and then it's going to go down into that ampulla. So here's our blown up picture. This is the last slide I wanted to show you. So here's our gallbladder. Picture our liver lying over top of this. And here's our gallbladder. So a gallbladder is storing bile and bile salts. And when it's time, when there's a fatty food meal on board, we get the chemoreceptors to say, hey, it's time to start secreting some bile. Here comes some fat. And fat is good for us too. We need good fats and we need bad fats. So whenever fat comes on board, let's say we're eating a handful of nuts, the body says, okay, here comes some fats. Let's start secreting bile so we can handle this. So the bile comes out of the cystic duct, because gallbladder, the word for bladder is cyst. So it's going to come out of the bladder duct, cystic duct. Up here in the liver, we have the right and the left hepatic ducts. So if we lose our gallbladder, this is where bile is coming from. If this is gone altogether, we remove that, we still have this. We're still going to be able to make bile in there. And those are going to come down the common duct, and then they're going to merge together. Well, those are going to come down the bile duct. And then they merge together in the common duct, and they drain down into the duodenum. So that's the hepato part of it. The pancreas is secreting lipase, and that's the pancreatic duct. So hepato, pancreatic ampulla, the HPA, ampulla is an opening. So we're secreting bile, we're secreting lipase, the enzyme that breaks down fats, and then we're going to start digesting fats. And where that happens is in the small intestines. So stuff is coming from somewhere else so that we can do the job in the small intestines. Make sense? But that's all of the bile stuff. We have gallbladder, so the word for bladder is cyst. What's exiting that is the cystic duct. If they're the two little branches up here in the liver, those are the right and left hepatic ducts. They're all going to come together and form the common bile duct, and then they're going to drain down into the duodenum. So we'll see that in lab as well. So here's your flow of how we're getting down there. And then things that go wrong is jaundice. Jaundice is an accumulation of bile in our a skin, a bile is kind of that greenish pigment, and it's gonna build up underneath the skin, and we're gonna get that yellowy color in our skin or in the whites of our eyes. So what might cause us to have a backup? Well, stones, that's easy. So if we have gallstones, just like kidney stones, it's gonna block this, and it's just gonna back up in our system. So that makes sense. Gallstones could cause a blockage. Cirrhosis, what we're talking about, alcohol destroys the liver. Excessive alcohol destroys the liver, and we lose that fresh pink tissue with all those healthy hepatocytes, and we get down into just a hard sclerotic liver. So it's backing up. And then, of course, hepatitis. Hep A, B, and C. Hep A comes from contaminated food and feces, so we think about restaurants and daycares, because you're handling babies for daycares, or workers, hepatitis A, if they're not washing their hands properly, and they go back and handle your food, so you can get contamination from daycares or restaurants. And Hep B and C are more bloodborne, needles, sex, blood transfusions, whatever. So B and C are much more needle, sex-related, blood, direct contact kind of things, versus Hep A is more of a hand contact kind of thing. Yes?
Okay, so I'm taking a nurse's aid class right now, and it's interesting to look at the different books and I guess how you can contract a disease,
Right.
the wording and what they say. Now, in my nurse's aid book, it says that you can contract Hep C from having multiple sex partners.
Absolutely.
Okay, so my understanding of that is if I've been with 1,000 people, I have it?
Most likely.
Wow, that's crazy.
You've been busy.
No, I haven't.
B and C is more like direct bodily fluids.
Okay.
So how do we get direct contact? Would be through sex, through needles, through transfusions. And remember we talked about hepatitis, what did we say, like 80% have it? What was our percentage that we said?
I think it's
A majority of people have hepatitis, we just haven't tested positive for it. And when we do test positive, then, like you guys all have your hep test, you have your hepatitis test, and you want to see if it gets swollen or itchy and then you're positive. So it could be from this up here. It doesn't necessarily mean bodily fluids, but you could have slept with one person and they slept with 1,000 people and you got it from that person, because the chances are huge that they have it and then you get it from them. So it's really easy to get it. And it says the majority of us have it, we just don't know until our immune is compromised, and then it starts to manifest. So you can have it and be a carrier and never have symptoms of it. And until your immune gets weak enough, then it will come back.
Yeah. It's
All right, so that is, and hypertension, sorry, one last slide, I didn't say that. Hypertension goes along with the liver, so if the liver's not functioning properly and clearing and cleansing, it gets full of scar tissue, and then we can't move things through. The veins the drainage becomes backed up, and that's where the hypertension comes from. So it leads to portal, having to do with the liver, hypertension. And then we have, Medusa. What does that sound like? Medusa?
Oh,
Yeah. We see around the navel is we get lots of blue vessels, and it looks like Medusa, lots of snakes. So we see that's a sign of portal hypertension, is we'll see lots of veiny stuff around the abdomen. It's very noticeable around the belly button. And then ascites is accumulation of fluid, and again, this is the liver's not clearing, it's backing up with fluids. And how you test for ascites is you put your hand in the middle, you hit over here, and you can see waves of fluid in there. So it's not just like, it's not like fat, it's edema, it's fluid in there. And so it'll ripple when you do that. You hit hard here, hopefully nothing's happening when I do that. But you'll see the waves of fluid go across because the liver's backing up and it can't get rid of all that fluid that's in there. So things. All right, now we're stopping. So we'll stop with the pancreas. We've got about 15 more slides, and then we'll be set for what we're going to do. So everything we did here is what we're going to find in lab this